19 deals with Jupiter and Sun and Earth. It deals with orbits and how the time period of an orbit is related to the radius of the orbit. Alright, and essentially Kepler's law. So the question says, and I should do this, question number 19. And the question says, Jupiter is 5.2 times farther from the Sun than Earth is. And so what is the length of Jupiter's years in terms of Earth years? So how many Earth years make up one Jupiter year? Okay. So as I said, when I read this question, the first thing that appeals to me about this is that I cannot do this using mg or mb squared by r or any of those things. So I must have a formula which is different from all that. And there is one, right? And it's called Kepler's law, which is that the time period of revolution is proportional to the cube of the radius of revolution. Okay? So if we do that, we can say that the time period of Jupiter's revolution square proportional to the radius of Jupiter square cubes. Similarly, the radius time period of Earth's revolution square is proportional to the radius of the Earth around the Sun cube. Now we take a simple ratio here, and we can say that since these two things are proportional, we can write this. Alright? Having done that, we isolate the two and we write, we take the squares outside, whole square, and we take the cubes together, whole cube. Now, what is it? Now we go back to the question. Now this is how we set up the question. This is our basic law that we've used, Kepler's law. And from Kepler's law, we have been able to relate the time period of revolution of Jupiter and Earth to their radius of revolution. Okay? Having done that, the question tells us that the radius of Jupiter's revolution is 5.2 times Earth's revolution. So this is simply 5.2 whole cube. Right? Now, doing a simple manipulation, I get Jupiter's revolution is 5.2 to the power 3 divided by 2, that of Earth. So, which gives us 11.9 TE. And that is our answer. So, which shows that for every 11.9 years that the Earth goes around the Sun, which just basically shows that the Jupiter takes 11.9 years to complete one whole revolution around the Sun, while the Earth obviously takes 1 year. Right? So, doing a recap, we identified that this problem had to do with Kepler's law because it talks about planets and revolutions and radii. So, we wrote down, we recalled that Kepler's law is this. Then we set up a ratio of the two planets and the time period of revolution and the radius of revolution. Then we used what was given to us, which is the ratio of the radii of revolution. Having done that, we were able to estimate the ratio of Jupiter's time period revolution to Earth's and hence get the answer. Okay, so this is a straightforward but an important concept to know and quite often shows up in your exams. Thank you.